Hello and welcome back to STEAM It with Steve. Today we're going to keep going on with our algebra exploration and we're going to move into how like terms look. So let's dive on in. So there's a bit of a meme for you. Basically you should be able to look at this and see that they're not like terms with the first one, whereas the second one you can obviously see that there's an x and then there's an x. And that's really important when we're looking at like terms. If they don't have exactly the same variable, you can't merge them together. That's really, really critical. So the golden rule we've done before, if it's the same, it's good. If it's different, it's bad. Hopefully we've got a little bit of brainwashing happening there. And then we've asked before, what is a variable? So a variable is a holder for any number. So imagine like a bucket, and inside the bucket you can store memory into it. You can look what's inside the bucket and do some really cool stuff with it. Now usually we use variable letters, so like A, B, C, D, E, F, and so on. And we try and make sure that this variable letter represents the thing. So if we're doing area, an A for area sort of makes sense. If we're doing length, an L for length sort of makes sense. So we try and make sure that the variable lines up. The next question then is, what is a term? So a term is made up of three things. It has a symbol, it has a number, and then it has a variable. So in this case, I don't have 3 apples. That's the way that I would read that. Then the coefficient is basically the number and the symbol that is attached to the front of the variable. So the coefficient in this case here is -3. So that represents the quantity of the apples that have happened. So then we looked at like terms before. So we've done this example. So 3 cats plus 2 cats. As long as they're both cats, we can merge that together and get 5 cats. So same when we deal with letters. If we have 3C plus 2C, because the C is exactly the same, we can merge those together. Because those terms are exactly the same, we can put those together, which is really, really important. So when the terms are exactly the same and have the same variable, you can merge it. So in this example here, you've got 2 cars plus 3 bikes and plus 4 cars. You can merge the 4 cars together and get 6 cars, but you can't add in the bikes because they're different. Now they might look the same, but they're not. Okay, now that's really, really important. So in this case here, we've got 2 apples plus 2 bananas. If we're trying to group those and make the like terms and simplify it, we look at that, there's 2A, and then we've got that, which is totally different. So therefore, that is as simple as it can become. Now that's important. So please, please, please don't merge these together and make it 4AB or something weird like that. They're clearly apples and they're clearly bananas because they've been separated. And hopefully you can see that with the image that I've put over the top of it. So for the first challenge, see if you can do this one. Just pause the video. So hopefully you've done that and you can see that this is an X and this is an X as well. So therefore that is 6X. You can merge those together and reduce them. So what about this one? Just pause the video, have a go. So in this case here, the A's are the same and then the B is separate. So you've got -5A plus 2A. So if I took 5 and then gave you 2, overall you'd still be unhappy. You lost 3. So in this case here, -5 plus 2A, we would do that first, and then we would add on the 6B at the end. So we get -3A plus the 6B. So next challenge, have a go and see if you can do this one. Awesome. So you should have seen there's the X's and Y's. So we have a 4X plus 5X, and notice that the symbol attached to the term is right next to the left of the number. And that's really important. So this plus is attached to the 4, this plus here is attached to the 5, and this plus here is attached to the 5x at the end. So 4x plus 5x gives us 9x. And then we look at the different terms that we have inside here. So we have 4y and 5y. And we add those together and we get 9y. So in this case here, we have 2 A's and X's. So we got -11A plus 7A. Right, so we need to, and this is why we spent time doing the adding and subtracting of positive and negative numbers. So that gives us -4A. We then have -2x minus 6x, which then gives us -8x. Then we have the next one here. So we've got 12x plus 8 minus 3x minus 15. So in this case here, we don't just have variables, we also have constants. So the constants here have no variable attached to it. They're just clear-cut numbers. Whereas these ones here, they're coefficients that are attached to these variables. So in this case here, we have 12x minus the 3x, which gives us 9x. And then we have plus 8 minus 15. So it's the same as me giving you $8, but then ripping away 15. So that gives you -7. So then in this case here, a little bit different. We've got an A, we've got a B, and then we've also got a thing called an AB. Now, an AB is not the same as an A or a B separately. So because this is A times B, this is a separate term. So in this case here, we have a minus 3A, and then we have a plus 6A. So if we merge those together, that becomes just 3A, because it's the same as me taking away 3 but giving back 6. Then we add a plus 2B, and then we just leave the minus 5AB. That is a separate term. And that's really important to understand, that even though it has an A and a B inside of it, it is not the same term as an A or a B just by themselves. So have a pause of the video, see if you can do this one. Awesome. So I'm going to show the wrong way of doing this one. So if we look at this, we have an XY and then we have a YX. So in this case here, a lot of people would have done this. So they would have had 8xy plus 3xy to give 11xy, and then minus 5xy minus 1yx, which then gives you minus 6yx. Now this is actually wrong, because remember we talked about the communication law that we've done before. So x times y is the same as yx. So we could actually go one step further and swap this around. And here we can swap that around. So then it's 11xy minus 6xy, which then just leaves you a 5xy. So xy, just so we're very clear, is exactly the same as yx. And that's why we try to make sure that we use the communication law by ordering it in alphabetical order when we look at these variables, so we don't get confused. So in this case here, we had this. You can just finish it off and get the equals 5xy, just to tidy that up. So pause the video, see if you can have a crack at these guys. Great. So first one here are 5AB and 3AB like terms. Absolutely. 4A and 7B are not like terms. 4A and 3A are, and then 3x and 2xy are not. So even though it's got an x, this thing's got a y as well. Which of the following pairs are like terms? So yes, this is. No, this isn't, because it's got an A and a B. And yes, this one. So even though the order is slightly different, AB is exactly the same as BA because of the communication law we've done before. Simplify the following by collecting like terms. So 7B plus 2 plus 3B, that becomes 10B plus 2. And the last one, we've got 12xy squared, 4y squared x. And because of the communication law, we can swap that around. And yes, they are like terms. So a little bit harder one, if we were trying to express the shape of this one as a perimeter, we would go the perimeter is equal to 8x plus 6x plus 8x plus 6x, which equals 28x. And that's basically grouping the like terms of the x all the way around the edge there. So pause the video, see if you can have a crack at this one. So this one a little bit harder. So there's a perimeter of this triangle, and see how you go. So we can see this triangle, if we were secured the perimeter going all the way around the end, you would have 2c plus 2d plus 6c minus d plus 4c minus 2d. So that's basically all the terms jammed together in one big super formula. And now I would group all the c's. So 2 plus 6 minus 4, which then leaves you a 4c, and then 2 minus 1 plus 2, which then leaves you a 3d. So that's pretty much it for me. There's a Dr. Frost here to have a crack at. Really important to try and group those like terms and see how you go with it. If you have any questions, please put them in the comments down below. So that's it from me. Hopefully you've picked up that you need to make sure that the terms are exactly the same. Otherwise you can't merge them together. If you did enjoy this video, please give us a like and subscribe, as it does help with our YouTube algorithm. So that's it for me. Thanks again for watching. See you next time on Steam It with Steve. Adios.